few final ways of representing our data. We've seen just our regular bar graphs. We've looked at pie charts and histograms. So now we have the last little bit, we're looking at what are called frequency polygons and time series plots. We do have a couple definitions that you need to kind of know what I'm talking about. A class midpoint, so these you'll just need to write down in your notes. It's basically just like a midpoint in algebra. You add them up and divide by 2. So it's the sum of the lower class limits divided by 2, and I'll show you exactly what I mean by that in a second. And then we will be looking at a frequency polygon. I'll quit talking and let you write. A frequency polygon is really just kind of like a line graph. So you plot the point, you connect them with a line, but it has a couple special properties. When you put the points, so we use this when we have classes of data. I'm going to go back and reference that Old Faithful example that we did before. So we had the 670 to 679 and the 680 to 689. Remember, we had broken into classes like that. Since your x value is really a range of values, you have to pick one of those to put your point at. So we'll put the x value, we'll use the midpoint. And then we have to connect the ends to the axis. So this example, I apologize if it is kind of small there. It's printed on your note sheet if you can see it. So this was the chart that we had made in our notes before using the same data. If I made a frequency polygon out of that, so the midpoint is the sum of the lower class limits divided by 2. So for this first midpoint, you take those two, so you would do 670 plus 680 divided by 2. So my first midpoint is 675. Okay, the next midpoint you would do 680 plus 690.
Sorry to interrupt.
No problem.
This guy's following me out. Give me some cash.
And so if you add those up, divide by 2, you get 685. Now, really, remember, we've already talked about what was our class width on this? How far was it from the beginning of one to the beginning of the next? So if you just find your first midpoint, all you have to do is add 10 every time to get every successive midpoint. So you don't actually have to calculate it every time. You just find the first one and then add your class width to get all the others. So when I plot this, my x value will be this midpoint. And then my y is our frequency. So we look, the first point I gave you was at 665, was at 2. 685 was at 0. And we plotted each of these. Now, I have some points on here that were not a part of the original data. Did I actually have a point at 665? No. Or down here. But the thing about a frequency polygon, it's basically showing area under a graph, and so it always connects to the axis. So essentially you will add a point before and after at 0 every time. To find those x values, you just have to follow the same pattern. So if I'm looking at like this data, my last midpoint was at 635, so at 645 I'd be back to 0. The first one at 675, so you would have to go before that would be 665. You would be at 0. You can graph that for frequencies or relative frequencies. They're going to look exactly the same except for the numbers on your y-axis. So the shape is the same. It's just a matter of if you use frequency or relative frequency there. Okay, just like with the bar graphs and the histograms, the shape doesn't change. Let's talk about how to do that on the Chromebook real quick. So open up Google. And so you've got your midpoint and frequency, but you add in the point before and after with the frequency of 0. Then we should just be able to insert a chart, and this automatically came up with what I wanted, but if it didn't, then you just select. So, you know, we've been doing these column charts. This time I wanted the line chart. All right with everybody? Sometimes we might talk about a cumulative frequency distribution or a cumulative frequency relative distribution. And so all of that is, it's basically every frequency up to that point. So you're just adding on the new. So instead of saying I had 2 the first time and 0 the second time, I had 2 the first time, at the second time I still have only 2 because I didn't add any new ones. So I'll let you write these down, then I'll show you an example of what I mean. So cumulative frequencies, you're just adding every frequency up to that point. Relative frequency is the same, you're just adding every relative frequency up to that point. So like in our Old Faithful example that we've been looking at, if I wanted to make a relative or a cumulative frequency distribution, so my first frequency was 2, my next one was 0, so 2 plus 0 is still 2. Next one was a 7, so 7 plus the 2 that had already happened is 9. Next, if you add 9 more, it'd be 18. If you add 9 more, 27. If you add 11 more, 38. If you add 7 more, it's at 45, which we had 45 original points. So it's basically just saying how many have happened up to this point. When you do the cumulative relative frequencies, what should your last one be? 1. Relative frequencies always add up to 1. I'm not going to use this one much. Just wanted to show you what it was in case you were ever looking at a graph that had it. It's just all the frequencies up to that point. The graph for these, I am not going to assess. It would just be like plotting the midpoint and the frequencies. It actually has a different term. It's called an ogive. If you ever hear that term, it's just all the frequencies up to that point, but I am not going to include that one on any tests or anything. So the last thing we have is time series data. Is just when your data is measured at different points in time. And when you graph those, it's what's called a time series plot. So in those, your x-axis is always some unit in time. So it might be minutes if you're talking about a chemical reaction that's occurring. Your time might be in seconds, or it might be in minutes. It could be in years. If I want to look at population trends, then I would be measuring every year and looking at the population. It's just another line graph that's talking about periods in time. The only way this is different than the frequency polygon is frequency polygon has to connect to 0, and this one does not. I would have you make these in Google Sheets. This one just has a year and the closing value of the Dow Jones, sorry. So all you have to do, make your 2 columns in Google Sheets, insert graph, and pick the line chart. You don't have to add in any extra points. You're just looking at those actual numbers. Is that okay with everybody? So that is actually the end, but I did want to maybe look at one example out of our books together. So if you could look at page 98. number 5 together. I'm going to have you do number 6 on your homework. So I want to look through one where you actually have to read a graph, not just me. Okay, so this one shows the frequency polygon for cumulative grade point average of a random sample of students at an engineering school. Okay. Part A. What is the class width? So class width is how far it is from one to the beginning of one class to the beginning of the next class. Now, these numbers here, if we're looking at a frequency polygon, the 1.25, 1.75, those are the actual midpoints of the classes. But the class width is the same. How far is it from one to the next? 0.5. If you did 1.25 minus 0.75, we get a class width of 0.5. Does everybody see that? Okay. How many classes are represented? Remember, the first one and the last one are made up. So how many do we actually have? 6. Just counting those x values, excluding the first and last. B, the midpoint of the first class. Remember, in a frequency polygon, the numbers plotted are the midpoints. The first point is made up, so what's the midpoint of the first class? Okay, now we have to think a little bit. What are the lower and upper limits of the first class? These are the midpoints, but the true one started in the middle of this, right? So if you wanted to find the middle of that, if you couldn't tell, you could always just add them up and divide by 2. So you would get 1. So it starts at 1. Okay, the class width is 0.5. So that would say 1.5. But remember, class width is how far it is from the beginning of one class to the beginning of the next. So that means this class starts at 1. The next one has to start at 1.5. We'd have to go to 1.49 because if we look, we have like 1.25. That's 2 decimal places. So we'd have to take it to 2 decimal places. So we'll have to stop this one at 1.49. That is probably the hardest part right there. Does everybody understand how I got those numbers? You find where it starts. Class width tells you where the next one starts. So we have to stop it right before. So the next one started at 1.5. If we stop before that, we get 1.49. Okay, C. What is the midpoint of the last class? Okay. What are the lower and upper limits of the last class? So if you look at that last one, 3.75, where would it have started? 3.5. Okay. We know the class widths are 0.5, so the next one starts at 4. So where would this one have to end? Good. All right, D. What are the lower and upper limits of the class with 25 students? So which class has 25? 2.75. So that one would start at? Start at 2.5. 2.75 is the midpoint. So the real class started at 2.5. Would have to end at 2.99. All right, E. What are the lower and upper limits of the class with the fewest students? So which midpoint goes with the fewest students here? 1.25. We've already kind of talked about that one. It started at 1 and ended at. So that's the part I really wanted to talk about. Sometimes when you're looking at those midpoints, it can be a little confusing trying to figure out the original classes. Are we okay with that? So you guys have over 20 minutes now to work on this assignment.